All right, guys, this is the video that's going to talk about the chi-squared test for association/independence. There is almost no difference in the chi-squared test for homogeneity and this one. As a matter of fact, it's completely identical except for the name, the hypotheses, and the conclusion. Everything else is exactly the same. And because of that, students tend to get confused about what to use when it comes to a question with chi-squared. They don't know to use homogeneity or association/independence. The only way you can tell, the absolute only way you can tell which chi-squared test is appropriate is described on page 719. The top paragraph says that it's easier to look at how the data is produced. If the data comes from two or more samples, then you use the chi-squared test for homogeneity. If it came from a single random sample, then use a chi-squared test for association independence. So that's the giveaway on what you use. That's the only giveaway. You have to read the problem and see, did it come from more than one sample or just one sample. All right. So because of that, I'm not going to work out an entire problem, but I do want to talk about the example on page 719. It's basically asking, are men and women equally likely to suffer lingering fear from watching scary movies? So this is association/independence, not because of that question, but because of what's said after that. Asked a sample of 117 college students. One sample was taken, then it was broken up into males and females after the sample was taken. So that's what causes it to be association/independence. The hypotheses for these tests, you can name it one of two different ways. You can use the word association or independence. So for instance, in this problem, the null hypothesis could be there's an association between gender and lingering fear effects from watching scary movies. The alternative would be there is an association. I don't know if I said there is no association a while ago, but the null is that there's no association. The alternative is that there is an association, ... Or you could state that gender and suffering from lingering fear from watching scary movies are independent of one another. That would be the null hypothesis. The alternative hypothesis would be that they are dependent. And then, like I said, everything else is exactly the same. Your conclusion is going to be based on your p-value. Obviously, if it's less than alpha, you reject the null. If it's greater than alpha, you fail to reject and put it in context of the problem. Now, so like I said, I'm not going to work out a problem, but if you go through the example on page 719 and it continues on page 720, it will explain it in detail. Now, there's one thing I haven't talked about yet that's important that may come up on the AP test, and it's the Minitab output that you see in some of these examples, and they do it here on page 719. So I want to talk about this Minitab output is actually from this two-way table right here. Notice the top number in each of these cells. There is actually 4 cells here with 3 numbers in each cell. You see the 7, the 29, 31, and 50. Those are from this table right here, 7, 29, 31, and 50. The number directly below those are the expected counts for each of the cells. So the expected count for that cell is 11.69. The expected count for that cell is 24.31, and so on. Then the last number is this cell's contribution to the chi-squared value. Now think about it. The chi-squared formula is the sum of observed minus expected squared over expected. So if you do 7 minus 11.69 squared divided by 11.69, you get 1.883. If you do 29 minus 24.31 squared divided by 24.31, you get 0.906, and so on. So therefore, this number, the bottom number for all four of these cells, add up to that value, 4.028. That's the chi-squared value. That is the number. That's the contributor for each of these four cells. The biggest number out of these cells tells you which one is contributing greatest to the chi-squared value. And as you can see, all of them are 0 point something, except for this first one, 1.883. So that tells me that this cell is contributing the most to the chi-squared value. Well, what does that mean? That means that this one is influencing it the most, that it's causing the p-value to be what it is, 0.045. Because we know that a bigger chi-squared value is going to give us a smaller p-value. So if you look, the observed count for the males was 7. The expected was 11.69. So there are a lot less males than we expected that experience fright symptoms, because we can see that fright symptoms, yes, male is 7. We expected 11.69, but there were only 7. So this one is the one that is affecting this the most. You may have a question like that on the test that says what cell or which cells are contributing the most to the chi-squared value, and you will say, in this case, this one is, and it doesn't hurt to say in what way is it affecting it. Here, it's affecting it because there were a lot less males that said yes than we expected. So you can just see how it's affecting it based on these numbers. If this number had been bigger than the one below it, then obviously we would have a lot more than expected. So that's how you read that. There's always going to be 3 numbers. The top one will always be observed, the middle will be expected, and the bottom number will be the contributing value to the chi-squared. All right, so I think that's about it. I hope that Ms. Collins has told you guys that you are going to be getting a take-home test on chi-squared over spring break, and you're going to be given a take-home quiz on Chapter 12, Section 1, because that's pretty much all you need to know from Chapter 12. I'm not going to give you a full-blown test. I hate that I had to do this to you guys, but it's really important that we finish the curriculum by spring break because we want to hit the ground running with review once spring break is over, because the test, the AP test, is May 11th. It is fast approaching, and we need to make sure you guys know your stuff. All right, that's it.